Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about a non-preemptive scheduling algorithm that is a first come first serve or FCFS algorithm, the mechanism to implement that and the advantages and disadvantages of using that algorithm. As we know, the CPU scheduling algorithm may take into account the jobs that must be executed, the numbers of registers available, the number of CPU time and the speed of CPU all. Now, we will see an example of priority scheduling and non-priority scheduling. The first one is a non-priority scheduling with an first come first serve FCFS scheduling algorithm. Now using this algorithm, we can implement it as a FIFO queue, that is a first in first out queue. The process we will request for the CPU first will have to be served first. Now when the process enters the ready queue, its process control block or PCB is then added to the tail of the queue, and when the CPU is free, then the termination of the process is then continuing and the new process is then gone for the ready queue at the head. Now the running process is then exited from the queue and the next process is then ready for the queue. So this way these queues can be solved and the CPU scheduling can be done. So we will see with an example then how to implement this FCFS algorithm. Here you can see that we have three processes with their burst times. So as FCFS, the P1 will appear first, allowing no arrival and waiting time, and the P2 will come then and the P3 will come then. So we will calculate the average waiting time for the intact scheduling also. So as P1 is arriving first, so we will allocate the memory for P1. Here the arrival time is 0 and it is taking 24 milliseconds to complete its execution. So when P2 is arriving, his arrival time is 24 milliseconds because it has to wait for this much second to complete P1 its execution. So now we will allocate the CPU to P2, which will take a 3 milliseconds of time. So we will add up 3 with the 24, that is in 27. The P3 has to wait for 27 milliseconds to start its operation. Now we will allocate P3. Now the scheduling is completed within 27 plus 3, that is 30 milliseconds. Now we will calculate the average waiting time for the entire process scheduling. So for P1 it is 0 seconds, for P2 it is 24 seconds, and for P3 it is 27 seconds. So here the average waiting time, as you can see, is 17 milliseconds. So this 17 milliseconds is taken by the CPU to complete its scheduling. But as we can see that if the arrival is like that, P2, after that P3, after that P1, then what will happen? First P2 is arriving with a burst time of 3 seconds. After that P3 is arriving and has to wait for a time of 3 milliseconds. After that P1 is arriving and which has a waiting time of 6 milliseconds to start its execution. Which will complete its execution in 30 milliseconds. Now if you can see the difference in average waiting time, let me calculate it that first. For P1, it is 6 milliseconds. For P2, it is 0 milliseconds. And for P3, it is 3 milliseconds. So you can see the entire average waiting time now comes up to 3 milliseconds, reduced from 17 to 3 is a huge. So the FCFS average waiting time is not minimal, and substantially it can be reduced if the CPU burst time differ and the arrivals of the processes can differ in this way. Thus, we can use FCFS when the burst times are similar or altogether with a minimal difference. Suppose if you can, this example we are using in a performance testing of a CPU bound process and some IO bound processes. Then the CPU is executing for 24 milliseconds for a P1 process which is CPU bound. Then the IO has to wait in the ready queue for this 24 milliseconds as the CPU bound processes has more priority than the IO bound processes. When the IO processes like P2 and P3 is executed in this ready queue, after that the CPU has to wait. Quickly it can accomplish its task, and then the again CPU task can be processed in the ready queue. This way FCFS can make a convoy effect which is known due to the idle and waiting time of the CPU and IO bound processes. That is why, and also for the non-preemption of an FCFS algorithm, we can use this FCFS as minimal possible as much. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.